Hello everyone, welcome to Maths Bridge. We shall continue our exploration in machine learning. A train and learn approach always bringing us to get to know the new concepts every time that you learn, and then adding a new item into a knowledge base is essential for us in day-to-day work life, isn't it? So today we will look into how traditional programming is different from way of doing things in machine learning. Without further delay, let's get started. For more learning videos, please do visit us at our YouTube channel at Maths Bridge. Okay, please do subscribe the channel if you are yet to be. Thanks for all your support. So I'll let you actually recap of a traditional programming way of doing things in your day-to-day computer programming lifestyle. I'm sure you are one of the IT, consultant or the programmer. In the sense, like you should know, like the traditional programming meaning like the programming languages like a C, C++, Java, object-oriented program way of doing things, and JavaScript and Python programming, and then many more like in ASP.NET, C Sharp, things like that. So all this programming, all you have to do is like understanding the programming way of actually implementing certain things. Let's say you have trying to solve a specific problem on a specific a domain, business domain, and then in a given domain, the problem is what your key to solve it, right? So for solving that kind of problem, what you do is that you are trying to build an algorithm, isn't it? Algorithm, is kind of like a sequential steps, some sort of a rules that you use to solve the problem. So by doing that, so what I can call that as like in a program, a computer programming. And then how to implement it, you you can implement this program in your interest of the programming language that you choose for developing all the solution implementation, isn't it? I for instance, I can call it as a program, a computer programming, a computer, instructions which we use to execute the code on the computer, isn't it? So this program requires some sort of inputs, right? So I program takes an input and then process it and produce an output. That's why I can represent it as a computer takes the input like in a data in as an input, program as an input, and then produce an output. That is the analogy that I'm saying. An algorithmic solution of a problem requires a input data and the program to produce an output. See, in traditional programming, the when do we actually choose this one? The precisely we talks like it is best suited for a problems with a clear and a deterministic logic. Let's say you are trying to multiply two numbers, 2 into 2, 2 times 2. How much you will get it? 2 times 2 is nothing but 4. So let's say like you are giving an input as a 3 into 3, 3 times 3. How much? 3 times 3 is 9. So you always see like you are going to get a consistent output for a given input. That particular algorithm does consistently produce an output for corresponding input, isn't it? This is how we do in traditional programming. So giving a few steps in detail. First thing is like the traditional programming has a 4 takeaways. It is a rule based approach. Basically like you are trying to solve a problem, right? Then you make certain rules, a logic, to solve the problem, right? That's why I can call it as a rule based approach. Second thing what you require is like you need an input to produce an output, and then this output is kind of a predictability, right? It is a very consistent. And one more thing that you need to know is like how you're going to develop that particular algorithm. So basically, for which we need to know is like, the computer programming languages of your interested area. Let's say for for myself, that I am actually comfortable in writing programs in the Python, and hence I'm using like a Python programming. If I can look at like, my problem statement is like, how I'm going to add for given any two numbers of type integer. This is what the sample application look like my programming. So here I am actually going to start main, and then I read the input variable 1 and then variable 2 and then add them, because when you're reading these variables it is going to be converted into int from the string stream IO stream, then add them as an integer variable and print it. So I have a sequential some kind of a rules that I defined to solve my problem statement. This is what I'm saying. This is like a rule based approach, and then this requires an inputs in order to produce an output. And then I'm using here as a Python, for instance, as a development programming language, but you can write your own programming language of your interest, right? But the output is always like a consistent. You can easily see, you can predictability is very high in traditional programming what you are supposed to get as an output for a given input. So if you look at here, I'm actually giving input, one input as a number 2, and other input as a number 4. So 2 plus 4 is what my rule based algorithm produce the output. It process the input and produce the output which is of 6. Do you see that? This is how I think traditional programming works. In machine learning programming, you see things little different. Let's say you are trying to solve a problem in machine learning. So what it means, like in the problem domain, certain things happen, which is called an output. But how these certain things are happen based out of some inputs, that's called a data set. So data set, the data set as an input. You also know that like what happened corresponding to that input. Those things too are known to you. Now what you are trying to do, you are trying to establish some relationship between the input data and then outcome that you happen to see in the real world. So make use of these two, then you are trying to develop a program, right? Basically this knowledge you are trying to trying to give it to the computer, so that computer can learn by itself, to establish the effective relationship between the input data set to expect output to produce the program. That is how the first step that you are going to do in machine learning. So once you have the basic program is ready, then you are trying to do the few more test cases to validate that program whether really giving a desired output or not. If not, that you have to go back and actually train it. That's why the concept called it train and learn is widely used terms in the machine learning. Learning is basically like what, like you're training, yeah, in a way, right? And then you train and then you retrain. That is how you have to see. So in a machine learning algorithm, system takes the input data along with example of an output and create a model which establish some relationship between the input and output. So precisely we call the outcome, instead of a program, as a model, because we are keep doing a building a model until you get a desired output. Do you see that the kind of a difference that we are trying here? In machine learning, we use a data driven approach. So data is a key that we know. From the data only you are actually building a model. You agree? So model means like what? So from the given data, it basically should have a knowledge to identify some kind of a pattern matching, right? Recognize the patterns, which are way different from the traditional. In the traditional programming, what we do is like we define certain rules to solve the problem, whereas here look at the data and then recognize the patterns, similar patterns are the different variants of patterns. Those patterns is going to help you to predict the output, things like that. So to make it more a simplified version of saying, a machine learning model generalizes from the training data to make the predictions or the decisions. That is what the point that you have to make out. Now, what is mean by training and inference? So model is basically trained with given data set, right? That's called a learning. So building a knowledge, meaning building a relationship between inputs and output is what you mean by your training. So once you train the model, then what you have to do is like you test the model, you inference how this model works for a given input. Now you have to predict the output. So that's what you do in this training and inference, means like building a knowledge with various set of combinational relationship between the input and output. Now, what is meant by adaptability? The way that you are actually building a model such that it should be in a position to accept a new variance, new data. When you are giving a new data, maybe your model might not recognize. Then what you have to do is like you have to fine tune the model, retrain the model in order to accept and utilize that data to produce desired output from the new variance as well, isn't it? So that's why adaptability is one of the key takeaway in the machine learning. Clear? Now the question is like the development. So what exactly that you are trying to address in this development stage? It requires a data set and the knowledge of machine learning algorithms and techniques. That is what I think you are going to do in the next couple of the videos or in your curriculum. And then you have to understand is like what is mean by training data, and then how you are going to train the model, how you are going to validate the model, and then test the model, means like evaluating until you get a the right efficiency of the model by giving the right output accuracy, basically what I meant to say. And then you should be in a position to debug and analyze model performance and adjusting certain patterns as a fine-tuning parameters to give the optimum solutions from that model for a given data set. This is why machine learning basically addresses the four elements: a data driven approach, a train and inference, adaptability, and then development. Okay, for instance, like recommendation system for e-commerce solutions where we are using like a machine learning, and then a speech to text converter, and then many more. So let's look at this simple a diagram which illustrates how machine learning helps you to solve the problems. Let's say you have some data. This is kind of called as a data set. I'm sure I think we are not aware of what this data means, but I'm taking it as an example. Now I also know there is an output produced by this data which is actually tabulated like this number, some number. So both I'm now giving it to my as an input to my computer. So now the computer should have a knowledge, right? So so let's say like you are building a model which is basically establish the relationship between the input and output and produce the some sort of a output as a program. Let's say it produces something like this: a plus b plus c is equal to y. So 5 plus 5 plus 4, how much? 5 plus 5 is 10, plus 4 14. So you got a 14. 2 plus 2 is 4, 4 plus 10 is you're right, that's also 14. 6 plus 6, yeah, 12 plus 2 14. So I got a 14. So it establishes the relationship and then produce some kind of a generalization equation: a plus b plus c equal to y, right? So now this is called as a program or a model. This model is now generalizes for a given input data what would be the output, isn't it? So this is what we mostly see in machine learning. A model is a output of machine learning algorithm after being trained on a data. Make a point. In machine learning we use term deployment, right? Deploy the model. Prior to the deploy model, first you need to train the model. For the training the model, you need a data set of a given problem statement. Let's say you receive the data. So what you have to do, you have to do some kind of processing of a data, assuming that you have the processed data. For the processed data, what you have to do is like you divide the data into two slices, like a training data and testing data. Normally we use like 80% of data is considered as a training data, remaining 20% considered as a testing data. Your 80% data is what only you are going to use to build the model. Building a model means like what? For a given training data and then output, you are trying to create a model, build a model. This model is short of a program, right? This program is used for predicting a new set of data to recognize the same output, right? Learning or training means learning a model using a training data or train the model using training data. Both ways you can say it out. Okay, once the model is ready, and then assuming that this model is now can use it to generalize output for a given input, then what you have to think, you have to test the model, right? That is where you have to use a test data. So this piece of data is not which is not you used for train the model, right? Unseen data for the model. So now model is freshly looking at this test data and predict the output, right? So this is called as a testing the data. So training and testing are the two important things to find out how model working, meaning accuracy of the model can be derived from these outcomes. This is how a machine learning algorithm is being built before being deployed. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.